Hello guys, today I am going to talk about the mean value theorem and understanding and application in physics. The mean value theorem states that if a function f of x is continuous in a closed interval and differentiable on an open interval ab, then there exists a point c that belongs to a and b such that the derivative of the function exists. This means that there is at least one point c where the instantaneous rate of change equals to the average rate of change over the interval. To visualize and compute the mean value theorem in Mathematica, we use the following steps. Now let us consider a function f of x equals to sine of x. So this is the way to write any function in Mathematica. Now we want to compute the average rate of change. Now we choose the value where the mean value theorem exists. We choose a is equals to 0 and b is equals to pi by 2. Now in order to solve this, we consider the formula of the average slope, that is f of b minus f of a divided by b minus a. And if we want to take the numerical value, then we have to put n, which is a built-in function, and we write the expression in this phase. So this function is borrowed here, and this function a is applied here, b is applied here, and this numerical value we get 0.636622. To solve the mean value theorem equation, that is the derivative of f of c is equals to f of b minus f of a divided by b minus a, and in order to make a in order to find the point c, we solve this equation, which is d f of x as a function of x is equals to average slope. So this is a total equation. So we want to solve this equation for getting the value of x. So we get two values of x, but the apparent value is arc cos 2 by pi. So this is the value of c. So arc cos 2 pi is the value where we get the slope. Okay, so at point 2 by pi, we expand the original function, and this is the Taylor expansion. In order to get the tangent line at point 2 by pi, we make a choice of the first two values of the Taylor expansion, and we can plot the original function and the first two values of the Taylor expansion to draw the tangent line into the original function. So this, you can see that this solid line is the original function, and this dotted lines are the tangent line, with the line which passes through one point. So 2 by pi is the point where the average slope is equals to the mean slope. Okay, so to find the problem in physics, we make a choice of the equation of motion for an object falling under the force of gravity. So this is the equation of motion. So the distance as a function of t is appeared here, and we choose g is equals to 9.8, vi is equals to 1, and we compute the average slope of the distance at point t2 and t1. So t2 and t1 are the two time values, and when we find the average slope, then the average value of the slope is 20.6. Now, in order to solve the equation, we take the derivative of the distance equation with respect to t and make it equal to the average slope, and we solve it. And when we solve it, the average, the time value is 2. So at point 2, we make a series expansion of the distance equation, and we get this equation of line if we consider only the first two terms. Now, when we uh, make a plot of the uh, distance equation and equation of line, which we have obtained using the um, um, using this series expansion, then we can see that this equation of line is actually showing the situation where the mean value theorem is suggesting. That means there exists at least one point C where the instantaneous rate of change equals to the average rate of change over the interval. So the interval at this stage is 0 to 4, and at time t equal to 2 seconds, the instantaneous rate of change is approximately equal to the average rate of change. Thanks for watching.